All right. Still a series circuit, yes? All right. If we were to short around R1, well, first let's solve the parameters here. What's our total resistance? RT, 10K ohms. What's our total current?
1 million.
Now, we'll short around R1. Now, the voltage on R1 before we shorted was what? 1 milliamp times 1K, 1 volt. And on R2,
5 volts.
5 volts. And R3,
4 volts.
4 volts. That accounts for all the source voltage, right? Okay. If we shorted around R1, what happens to the total resistance?
Goes down.
It decreases, right? Because we remember the rule, which told us that if any branch resistance increases, total resistance increases. If any branch resistance decreases, the total resistance decreases. Yes? Question? Okay. So if we short around R1, our new total resistance would be 9K ohms. Okay? And then if we divided 10 volts by 9K ohms, someone got that?
1 million.
What's that?
1.11 million.
1.11 million. So we see that our current did in fact go up while our resistance went down. All right. And what then happens to the voltages on R2 and R3? Do they increase or decrease?
Increase.
They increase. Why is that?
Is that to make up for the voltage that was dropped by R1?
That's correct. They still have to drop the source voltage, right?
Yes.
Okay. Very good. And how did we define Kirchhoff's voltage law?
All voltage, all rises and drops. In a closed loop, have equal zero.
That's correct. The algebraic sum of all voltage rises and drops around a closed loop have to equal 0. Okay. And the voltage divider. Anyone remember the voltage divider? Because this can be an important application.
ES times R1 over R2.
Okay, so for the voltage divider, Sergeant Espedal, we said ES is equal to the resistor that we're looking for the voltage drop divided by the total resistance. So in this case, if we're looking for the voltage drop of R1, line V R1, that would be equal to the source voltage times R1 over the RT for this loop, but in this case, R1, R2, R3, right? Is that correct? Okay. This R1, R2, R3 is nothing more than the sum of the resistances for the loop, yes? So that would be, what, 4K? ES is 5 volts. And R1 was 1 K. All right, so mathematically, looking at this, we know that the Ks and the ohms would reduce to 1, yes? So I can erase those. Leaving me with 5 times 1, 5 volts times 1, which is 5 volts. Divided by 4. And what would that equal? 1.25 volts. So we found the usefulness of the voltage divider rule in finding a voltage drop without ever having to calculate what? Current. Any questions there? What is the characteristic of power in series? It's additive, right? Very good.